Hi, in this video we're going to do a couple more examples where we solve differential equations. Easy for me to say. Remember in a video before when I talked about this, I said that you want to get all your x's on one side and all your y's on the other. That includes your dy dx. So I want to get my y over here, my x over here. In this first example, and again I'm on page 420 from your text, chapter 6, section 2. I'm going to treat this as one thing, and I'm going to move this whole thing down below the dy, because then I'll have all my y's on one side, and then my dx will be on the other. So I can rewrite this dy y plus 3 and have that equal to dx. And now, just like usual, when we solve a differential equation, we have to integrate both sides. So I'm going to integrate each side. The integral of dx just becomes x, and now the integral, remember the integral of 1 over u, if I treat y plus 3 as u, is just natural log of the absolute value of u. So this becomes the natural log of y plus 3. Okay, and now plus I have to have a constant. And now what do I want to do with that? Well, I want to actually solve for y so I can get this as a solution. The way I get rid of a natural log because of inverse functions is that I can e both sides, okay? In other words, take everything to a power of e, okay? Right. Over here, e natural log cancel out, and I get y plus 3. And over here, I get e to the x plus c, right? And now, we haven't really talked about this before. It hasn't come up yet. It should be reviewed, but this e to the x plus c is equal to e to the x times e to the c. Remember, whenever we have like bases, when we multiply things with like bases, we add the exponents. And the reason I bring this up is because e to the c is just a constant. E to the c is just going to be another constant. So I can think of this e to the c as simply another c, okay? So now I can rewrite this to be y plus 3 is equal to c e to the x, okay? And this c right here is just coming from the fact that I've replaced e to the c with just another constant. And now if I just want to solve for y, I'd subtract 3 each side. So for my solution, I would get y equals c e to the x minus 3, okay? Let's try another example here, number 5. And in this example, I've written this as y prime, but we all know that that's the same thing as dy dx. And once again, I want to get my dx and my x variable on one side and my dy and my y variable on the other. And this one I can simply just cross multiply. All right. So I would have y dy is equal to 5x dx. And now I just want to integrate both sides, okay? Whoops. All right. Over here I get y squared over 2, because the integral of y is just y squared over 2. And over here I get 5 over 2, right? X squared. And now I can just plus my constant. And now I can just multiply everything through by 2, all right, to get rid of my denominator here. I can multiply this by 2, this by 2. And I don't really need to multiply the constant by 2 because that would just be another constant. The 2's would cancel, and my final answer would be y squared equals 5x squared plus c. And now I might want to write this because that's the equation of a circle like this. Okay. So that's 2 examples of solving differential equations. And again, I'll just go back to my previous point. You just want to get your dy and your y variables on one side and your dx and your x variables on the other. Then we can integrate both sides.